welcome back to my channel. So thanks for subscribing even before I release my first video. That shows me how you're interested in watching my all the video. Okay, so let's start with introduction to AI. Okay. This is not exactly same as what I did in Kannada. So this is differently, but re-recording again. With of course the concept will be same. With that what you in Kannada, what in English, but at the end of the day, both will converge. Okay, the way represented might be different, but at the end of the day, the both video remains the same. Okay. Now what we'll do is for this today's introduction section, we'll learn about AI, what is ML, what is DL, what is generative AI at a very 1,000 feet level. We'll just understand the basic. Remember, if you want to do only generative AI, ML and DL is optional, but knowing knowing at a high level, it's really important. So we'll understand. But if you know AL, ML, along with the DL or computer generator, all the three, then you can mix, match, and use based on your use cases. Many of the people will see that we can use the input from ML or a DL to the generative AI, or take the output of generative AI and give to the input to the ML. So those things also is possible. So what I will do is today introduction is a common. From going forward, we'll split into two tracks. So I'll create a two playlist. So one playlist I will talk on ML and DL going in depth. Okay. Another track I'll start the generative AI, which although won't be required to know ML and DL. So I will do the two parallel tracks. So if you are interested in only generative AI, you only continue those. You can skip those videos. In the beginning, I will mention if it is anything related to ML or DL, you can skip it. Anything related to generative AI, you can continue the journey. You can see now A2A and MCP is making a lot of noise and agentic AI. To catch up with what I'm thinking is we'll introduce at a very high level concept. We'll go through as quickly as possible with simple example so that you can catch up with the market currently, what agentic AI and everything, so that you won't fall behind. Okay. Then I will go with in-depth only. I'll go to in-depth, cover different topics so that you know what is happening in the current industry, current trends, along with the previous, you can catch up with the previous fundamental also. So what we'll do instead of, if you start building foundation slowly and then if you move to generative AI, then by that time it will take 6 months or 1 year. We're already with so many papers would have been come that time, and so we won't go to catch up. So we'll do that way. Okay. For today, what we'll do, we'll just do the introduction. However, you're free to comment below. If you want in a different way, we can do that. If you want a three tracks also, we can do. Anything is possible. Okay, this is for the community. I just opened because many were asked actually wanted to have a YouTube channel in speaking events, multiple in Microsoft, when people ask that to open a new YouTube channel so that we can make the understand easily for non-IT also or even for IT folk also. With a simple analogy, I will explain what is AI so everybody can understand. Even if you're not worked in a software or in computer, it's fine. As long as if you know to know operate a laptop, it's more than enough. You don't have to become a programmer, you don't have to be a software engineer. Okay. So without further ado, let's jump in. So let me introduce myself first. If you're not in, so myself is Manjunath. Full name is Manjunath Janardhan. I'm a currently principal AI engineer working at MSG Global Solution. Okay, before that I had around 20 years of software engineering experience. So past 3 years I'm working on generative AI. Okay, now I'm learning about machine learning and deep learning also along with that. Although as I told, primary GML deal is optional for AI engineer. And if you know, this AI engineer also came just 6 months or 1 year back. Before that, there is no such thing called AI engineer. So let me also introduce what is AI engineer actually anyway then. So any person or a person who develop a chatbot on top of existing software is the AI engineer. So his job is to write a software, still write a software, but only related to AI. Okay. So typically a software engineer before AI, if you 3 years before, if you ChatGPT, if you go back, so you used to write a software, right? For example, let's say WhatsApp. So WhatsApp is a software. We used to write a WhatsApp application is used for chat. I like to chat where make a group, send chat to a friend, make a call, and all the stuff. But when AI came, so Meta also added something called Meta, right? If you chat, if you go to search, it opens a Meta Llama, right? You can type, no, you try it, so you can chatting. So those guys who develop those software is called AI engineers. Okay, typically they are called AI engineers. Okay, okay. Now I'm also had one patent around 2 years back for generative AI applied for a patent and got the patent for the one of the idea. We'll discuss what the patent is also going further. I will explain when you go over tools and function calling when I talk about that. So I don't want to talk about much in my introductory video. I also speak at these multiple events. Recently, I started speaking around 2-3 months back. I started speaking in the events also. So my key expertise is on generative AI solution and microservice and the cloud, along with a software engineer. Okay. So let's about introduction. Let's dive into the topic. So as I told today as introductionally, I won't teach you all the mathematics or what is behind the thing. At a 1,000 feet level, let's understand what is machine learning and deep learning. At least you know if somebody asks what is deep learning and machine learning, you should be able to explain in one line, right? Even if a common man asks us, you should explain him what is machine and deep learning. Because this generative AI came after all this evolution of machine learning and taken. By the way, 1950 only the machine and deep learning came to, which is not a new actually, right? It is there in the beginning, but still we are using it every day. Okay, let's dive in now. So let's understand what is machine learning and traditional coding. So traditionally, how you to write a software, like for example, WhatsApp. We write it might be written in C++ or React or a Perl or a Python or any language, right? Yeah, so that's why we used to write the code and we develop a software. So usually we write the rules like let's open a WhatsApp. What is to show the chats? If I click on status, I can need to see able to see the status. So those are the rules you're going to write in the computer so that it will behave like that way. Okay, for that we should have some data also. We'll go to input data. What is the data in WhatsApp? You might tell hi to some message, send some message in the WhatsApp, right? So those are data. Okay, in simple terms, let's say if you want to write a program, a simple computer program to add two numbers. Okay, the data is nothing but your two numbers. Two numbers, what you give is data. The rule is addition. Okay, together it will do something, you'll get the answer. If it's an additional program, if I'm writing, so 2 plus 2, I will get a 4. So that is a simple way of traditional coding. So that is working fine. That's what the people used to do. Now, what is machine learning? Machine learning is other way. So what we'll do instead of rewriting a rules, this addition, a simple example. Okay, what if machine can identify by set of data by supplying, or can it able to identify machine can identify I am doing an addition instead of I am writing a plus b. Let computer decides. Computer learn from the data and do the addition of two numbers. Okay, we'll tell it. Oh, let's see that. So let's take an example of addition example only. Suppose say I will create an Excel sheet or some Excel sheet with two inputs. The one put says the input number A and other number put B. Okay, then also I will do the calculation of sum. So that I will prepare a data. Okay, so I have the both input and the output and feed it to the computer. I will have a 100 example. For example, A2, B2, output is 4, right? And 3, 2, 6. Like that, I'll collect 100 or thousands of data and give it to the computer. So the computer should learn and figure out I'm doing addition. Okay, that is the idea. So in other example, what you see here. So let's take a conversion there. Conversion, for example. Okay, let's see the conversion programming, right? Like we have US currency rate here. In the slide, what we were doing is you have a conventional conversion rate and US dollar. You feeding to the computer. It's again we are writing a rules. You will get a local currency, correct? But what is the machine learning? Machine learning is nothing but we just swapped it, which I already talked about now. We just simply swapping it. See, we take the answer, we take the data, let machine figure out the rules or a pattern. So what it does internally is basically it find with the data, it try to find a statistical relationship. So what is statistics? What static all thing will with a separate track going forward. For now, just understand it is something what happens is nothing but a statistical model. We call a model in the machine learning. In the traditional coding, we answer we call a program, right? We get a program, C++ program or C program. In machine learning, we won't call a program. So output will be a model. Okay, with that, we can feed the unknown data, we'll get the answer. A simple example, if you're not trained 6 plus 2, for example, in 100, if you feed 100 data, you're not trained 6 plus 2, ideally you should output what 6 plus 2? 8, right? 8 is so 8, you should write 8. But usually you won't get 8. We'll see that once the example going forward, usually you get something called 7.9987 or close to 8 actually, because those are probabilistic model. If you get the 8, then it's a different, something called overfitting is happening. Okay, we'll talk about it later. Okay, we'll talk, but usually you won't get the exact output. Remember one thing. That's very, very important. If I give 2 plus 2, you won't get 4. You will get 3 point some number or close to 4. Okay, that is the machine learning. Now you might ask a question, why do you need a machine learning? Why do I have a traditional coding? You might ask a simple question, right? The reason is being, we cannot everything can code what you see in the real life. Okay, let me take an example. See, I have an Apple Watch here. Okay, there's something if I can do workout. Okay, I can do yoga. I can select. Suppose if I'm planning to do yoga now, I click on the yoga. I'll do yoga for 20 minutes. Then it will calculate how many calorie burnt. Everything it will calculate. That's the one thing. If I do indoor cycling is there, your indoor walk is there, so I can continue to do that way. But assume that I want to write a program here, so that instead of I'm manually selecting it, okay, what I'll do, after doing 5 minutes of yoga or 5 minutes of walking or 5 minutes of jogging, it automatically should detect I am walking and start recording it. So it has an input parameter. It has an input of my heart rate, my age, my BMI, everything is fed, and pedometer if you're walking. So those are always tools available in my watch. Okay. So how do you write a program? Let's go back to the traditional program. How do you write? You can do it for walking. Maybe you can write when you pass walking between 10 to 20 kilometer per hour. Okay, walking to 10 to 20 kilometer per hour, or with the heart rate of going to 100 to 120. With the pedometer, with this how many steps he's taking, you can approximately, by seeing the data, you can write a one rule, right? You can write a program. Fine. But for jogging also, we can something where your heart rate will be more, the speed will be more. With that, you can do the run. For yoga, it's a little bit difficult. But say, assume you have calculated that you did a yoga and got the data, you had hard code that value. But how do you do if you're cycling and if you do indoor cycling and everything? It's get complicated. See, when you do swimming, how do you find out? So it gets keep on complicating. It may not be accurate also. It will be error prone. Correct? That is where machine learning come into picture. So where those cases cannot be solved, programmatically we do the machine learning. So how to do that? Very simple. We'll take the watch, we'll ask our 100 participant, we'll give 100 people watch having different weights, or different age, different BMI. Of course, everybody will have a different heart rate, right? So we'll give 100 watch, we'll ask them to, one day for 30 minutes you do walking, okay, the next day you do jogging, and next day you do yoga, and continue keep repeating, so that I will get around 100 or 150 samples. So it might take 6 months. By the way, everybody to the job with 3 months of data will collect from all the 100 people different data, and we collect all the data, and then what we will do, then we'll put data. We have an answer also. We have an answer like for a running, how much it is. We have so many data collected for 100 people, right? So many days we have calculated. Everything we'll put, and let the machine will figure out the complexity of the data. After that, when I put that model into my watch, okay, as soon as I started jogging, it will detect that I'm jogging and start automatically doing. So I don't have to write single line of code. I don't have to write a rules or a pattern by hand. So machine will do that. Okay. I hope you understand what is machine learning. So how it works internally will depth. It's not for today, just introductory video. Okay, we'll keep it for the later on. Just understand what is machine learning is simple compared to traditional part. We just simply swap answers to the question and it will find out the pattern. Okay. Yeah, remember data is very, very important. Data, why very important? If you have very less data, your model may not predict properly. So if you have more data, also if you have more data, it's very good, but it will take some time for training and machine to do find a static model, but you'll get a better accuracy and a better output. Okay, remember that. Without data, there is no AI. Okay. The second example, machine learning is also weather forecasting. If I see the weather, I see that tomorrow, I see that actually on Saturday there is a 35 percentage of rain, and Sunday is 40% of rain. It is telling there is no rain on Friday. Okay, today is Thursday. Well, at the time of recording, that is today. Saturday and Sunday is predicting the rain. How it is predicting? Nobody written a rule. How it is predicting for a week? They have taken the data from past 10 years of data, everything they have fed and trained the machine learning model, okay, and deployed. So with that weather station, we have deployed all this when that's why we're able to predict it might rain on Monday. Let's see if it rains or not. We'll see. That is a different story. But that's how the 35% is the chances by seeing the historical data. Okay, that is another example of machine learning. I hope you understood the difference between traditional coding and machine learning. With that, let's go into the next important topic. It's good to know these three because it is helpful to understand how generative AI is trained. That is the reason I am taking one step more to explain you what is machine learning. And again, it's only 1000 level deep, okay? It's on a very high level, 1000 level, we'll see. So that broadly divided into three is something called supervised, something called unsupervised, and something called semi-supervised. Broadly divided into three. Remember, it is normally divided into three categories. Okay, we'll understand what is one step by step with 1000 feet high. Very simple. The supervisor's name suggests very simple. So I have a set of photos of dogs, of different dogs, different angle. I will take a photo and also I will label it. Remember, I will label it. Labeling is the keyword here. Because I'm labeling label data, we are feeding for the training to the computer to find the pattern in between. We'll do that is called a training. Then hence is able to predict it's a dog. So that is called supervised learning. So if we train with different dogs and we take the unknown dog which has not been trained, it will predict as a dog. How? Inside the behind the scenes, it going to it going to find the pattern in between how it is that, how the dog looks like, and will be able to predict. If you put a cat photo, it won't answer today. It is not a dog. The model is trained only on dog. So if you try to put cat, it won't say. It will say it's a dog. Okay. Remember that is called supervised learning. Supervised is simple. You label data. Very simple. Understand how it is trained. Let's not discuss for today's topic. Okay. I hope you understood what is supervisory. Straightforward, right? Now unsupervised. Now unsupervised what? If you see the unsupervised, we have the label data, right? Here what you see, unlabeled data. That means we won't label it. We'll take a mix of, in this example, we're taking mix of rabbits, mix of cat, and mix of dog photos. We have taken that and give for a training. So what the model will do, it will do the clustering actually. It does the output will be clustering. Because you've given all unlabeled data, what it will do, it do something called clustering. What is clustering? It is grouping. It's groups. It's, if you see the right hand side, it groups dog separately, it groups cat separately, it groups rabbit separately. Correct? So this is called clustering. And then you can label this is dog and label everything. So it just do the grouping and leave it. Group 1, group 2, group 3 because it doesn't know what is cat and dog. Okay, it just do the prediction. This is called unsupervised learning. Okay, unsupervised learning. Simple, very simple, right? Next thing. So what is semi-supervised? Name suggests it's a mix of both the two, what you see. So take the labeled data, take the unlabeled data and put on the training. And if you put, this is cat and dog has been trained, labeled, but rabbit has not been labeled. But yet it is able to predict. When the person is able to predict a rabbit, okay, we'll see how it is that in the future chapter in the deep learning, machine learning and deep learning playlist. When you do the split, we'll see how it is actually predict even though we are not given the label. For this, for high level, you understand this is how semi-supervised learning works. So in the machine learning, you only have three topics, okay, three different branches. This is so the way we can go the track. Okay, this is semi-supervised learning. So next, talk about the next thing we call something called deep learning came into picture. So deep learning is nothing but inspired by how the brain, your neurons work. Same thing intimating in your computer to so that it can intelligently understand and we train the model network. Okay, simple thing. Since the machine learning is statistical model, but deep learning is not the statistical model. It won't use statistics. It uses only mathematical, like matrix multiplication. If you're not it's fine. It does the so integration. It does calculus. Basically, it does the classical differentiation or the integration. It does the calculus aspect basically. Okay, that is called deep learning in this case. Okay, so that can be used for both supervised, unsupervised, and semi-supervised learning. So you might have a question. You already machine learning is there, right? So why do you need a deep learning? Why do you need this actually? So it's very simple. For a machine learning, let's go back one step here. When I told about this semi-supervised and supervised, right? So this dog, how do you code in machine learning? Machine learning can't understand image. You cannot feed the image to the machine learning. It's all like weather prediction. How much percentage rain? Okay, and a watch. Whether I'm doing a walking or a jogging, it's just a one level prediction. Okay, it has input or numerical data. Remember in my watch example, input all numerical data, right? It's not any image feeding, my heart rate and all the stuff. So here I'm talking about the images. So it's very, very difficult to code images, okay, and do the machine learning training. So that is why they come up with a deep learning so that we can train images. Remember, okay, that is why reason. In simple terms, explaining in simple terms, when I go to the deep learning, along with I'll explain each and every one, but at the eye level, just understand deep learning where we have to train the images basically. Of course, you can use numbers also here. Nothing stopping you to do that, but just have to make the simplify easily to find the pattern in images. Deep learning, that's why they introduced. So machine learning is not suitable because they are a statistic model. Okay, that can be works on numbers, not in images. Of course, we can't convert images to numbers and do that, but that will be very more complex to do. The best and easiest way it would is deep learning. Okay, with that same supervised, semi-supervised, and unsupervised one can be done. We'll not go into deep learning because this is a very good, very branch, very broader subject actually to that. We'll cover in the later parallel session if you're interested. We'll cover this as part of this channel only. I have a different. We'll go in depth of the deep learning also. For now, you understand, deep learning is inspired from the human brain and it has all interconnected neurons from the network. Okay, that's all you understand. The whatever you see in the middle is what we'll see in the deep learning. So normally this shows that three input. This is called input layer. We call it as. Okay, let me also explain the one basic one. So this is the input layer. Okay, this is the input layer. These are all the output layers. Okay, what you see in the three called hidden layer. That's the term it used. Okay, we'll cover it anyway in the future, but understand there's something called input layer and output layer. There are three inputs and three output. Okay, what in the middle is called hidden layer. This is where actually the pattern will recognize based on your image. It's a dog or a cat. The features, it's called features. What are the features of the image? It will excite. Okay, that is about the deep learning. Now let's come to the AI. What is AI? Okay, initially I didn't put the AI because I want to completely cover the entire thing. So what is artificial intelligence? So that is for the being intelligent to computer, right? We have seen already. We have seen some intelligence in deep learning, right? The cat and dog, how we detect. We also saw machine learning also, an example for a watch. So it became artificial intelligence one time there. So in the artificial intelligence, a very broad topic. Inside we have a machine learning. Okay, in the machine learning inside is very deep learning. It's a more subset of the machine learning. And inside the deep learning, we have generative AI. If you ask me where generative AI, it comes here. So deep inside the deep learning comes generative AI. That means what you can understand. So generative AI is again is a part of deep learning, not the machine learning. Okay, means that has internally it have neurons. It has a brain, artificial brain. Remember, okay, that's where okay that is a deep learning. That's the model, advanced and sophisticated form of machine learning. Okay, and okay, why deep learning is so popular now? Is it because all because of thanks to NVIDIA GPU because they make it more powerful, able to run millions of competition, which earlier was not possible. Remember, 1950 deep learning came. It's not a new thing. And ChatGPT, the first one came very long back, right? The ChatGPT 1.0, GPT-1, but it was not very, very popular only because we do not have a much GPU hardware. Thing. Okay, we'll talk about that later. I'm saying how it become famous, we'll do in the going chapter, but understand generative AI comes from here, deep learning. That's all I wanted you to understand in the beginning chapter. Okay. With that, we'll go with the one thing, what is generative AI? Okay. For today, we'll stop it to understand what is generative AI. For today's our introduction video. Going forward, we'll take the generative as I told, we'll talk more on generative on track. Again, at eye level, with a very top level, we'll cover all the topics there. Then we'll go deep depth only. So that you will be, at least you know what is happening in this team and someone say A to A or agentic or MCP, you should understand what is that. Okay, we'll go to it. Bear me, probably within 1 or 2 weeks, I will make it everyone. If you have zero knowledge also in AI, it's fine. We'll take you to words going in industry, about industry, currently is A to A, how it works with hands-on. I will show an example, a simple example. Let's talk about what is generative AI. See, generative AI is what we're going to, so it's like a student learn by me. Okay, let's take another example. Okay, so say you have everybody have watched movies, right? Everybody has watched movies. You had to watch movies, right? Or you would have series. It could be anything English or your native language, whatever you have seen movies, something, right? With so many viewers you have seen so far. Okay, if I ask you to write a script for a movie, okay, it would not be a 2 hours or 3 hours movie, a 30 minutes or short film for 10 to 15 minutes. If I ask you to write a script, okay, you should be able to write it. Anybody, right? Even if you don't have experience. How? You can take the script into some movie, some series, you can take all piece, and try to we can make a small movie, right? Nothing funny. Just think about one of the movie. Okay, this scene is good. Let's take this. This comedy scene I will take from this movie. This action scene from this movie. This song I will pick up from this movie. Take that, and you can do and create a small movie, right? You can do it actually. See whether it's a hit or it's a flop is a different story, but you can do it, man. Generative AI is exactly the same. Okay, this is exactly the same. It has learned from the entire internet with all the thinking. Thus is able to generate a new content. Now only explain the difference now. Okay, the term generative. Why the term generative? Let's understand it first. Okay, if you see the machine learning and deep learning, they did not generate any content, right? What did the deep learning did? If I say what is this? Sorry, what if I say ask you what is this? The deep learning will predict say that this is a AirPod. Maybe up AirPod charger, right? It will predict. Correct? That's what. So what's we used to predict actually? It won't generate. Remember, it won't generate. Remember in machine learning weather example I gave? It won't generate anything. It tells that 35% chances are there is a rain. It won't it is pretty but it won't generate it. Okay, I'm automatically say it won't generate. But this is a generative AI, meaning it will going to generate something. You all use ChatGPT, right? You all be using ChatGPT. When I ask the question is simple, just which is the capital of India, it is answers, means it generated the content. It was not done in machine learning or deep learning. Okay, so that's why it's able to content. Now we may ask me, so that's why that is one of the example. The movie, you can write the movie. Same the generative AI is same, where it has learned from entire internet, so it's able to create a new content, able to generate the new content. That is the term generative AI. It's a very, very simple term. And by the way, this slide is generated by Microsoft Copilot slide and it's given me the answer. Simple. Its entire slides, this complete slide, including the image, this one single slide is by Microsoft M65 Copilot. See, it generated the content for me. I just asked him make a simple definition so that everybody can understand these very simple terms, and it generated me a image also. What is AI the left hand side, and also it has generated content for me. See, that's how I use the generative AI. I'll show you different tips going forward how we can leverage the existing one, but understand what is generative AI. Okay, I hope you understood. What example what I'm showing here is like a student where the child runs from reading multiple stories and he can write from reading the more many books and he can write his own story. Right? Same like a movie example what I given. Okay. So with that, I will stop with this here, with this final slide for today's introduction session. Since already covered what is machine learning and deep learning, the output is a model, right? But here in a generative AI, we won't call a model. We call still model, but we call foundation model. It's just not a model. Okay, we call a foundation model. There we call machine learning model, a deep learning model. Here we call a foundation model. Why the foundation? What is the meaning of foundation? Remember, unlike the previous section that trained with the label same set of data with doing a one simple for addition program, I explained you. For the walking and jogging, I explained you the same set of data. But here, what they did is they took the entire internet of text content, image content, speech. Even they took the YouTube videos. It has already trained with lot of YouTube videos. They trained with the YouTube publicly available YouTube videos and unstructured data. What is unstructured data? Your PDF content, your Word doc. Okay, structured data is nothing but a table format, like in Excel, which has columns and rows, right? Those are structured data. So this unstructured data is available in the internet, correct? So those data and spatial data, so all the data are trained and create a foundation model. You might ask, is it supervised or semi-supervised? You might ask the question. Since they put all the unknown data directly in one thing, it's a semi-supervised. So some are labeled and some are non-labeled. So it's a semi-supervised learning. The entire data they train and create a foundation model. That's why to create a foundation model, it took 3 months with burning a lot of money to get GTP 3.5 in so many parameter. And what it can do, it not that one job. It can do, you should be already know by this time, it can do word completion, question answering, right? It able to do the code completion, you can code it for you, or like web coding, it can do entity extraction, image caption, so on. See, okay, sentiment analysis, everything can be done, multiple tasks can do. That's the power of foundation model. Okay, so I think for this thing, for this level, if you're understanding what is machine learning, deep learning, and what is the foundation model, okay, is fine. So going forward, I'll keep going with the what is generative AI. Will continue the one track as I told you before, and we'll also continue ML and D in a separate track. Okay, we'll have a small 25 to 30 minutes video so that you can easily digestible content. Okay, and also if you have anything, please put it in the description what you want to different to see. I can also do a separate track, also separate videos for that. I have a different playlist in the same channel what you're having. Okay, it's up to you. So please do comment if you want anything, if you want any other topic to be covered. Otherwise, I'll go with the slow flow with all the basic top level view of a view of 10,000 feet of complete understanding up to A to AGI. Then each one will take and go as much depth as possible so that you can also put it in a day-to-day life, in your work. You may be a startup, you're working in a startup company or in the software company or non-IT company, anything you can put your day-to-day life. Okay. With that, one last thing I will want to close that. Even if you're not in IT and non-IT students also will benefit. How? Because I started 2.5 or to 3 years back, I took my son's exam timetable and exam portions, created a small rag, okay, created a small rag and started create a chatting model, everything on my laptop. That's the first application. It made my life easier. Why? Because I don't have to go and see two PDF document. One PDF has my exam timetable and another PDF as the portions. So I clubbed together, I put it on my laptop, I had Llama installed on my laptop and created a rag out of it. I created a UI and then digital chatting. So that's why you so that think about if your use cases. You can do it for your cases. No matter where you are, you can still use generative AI because generative AI is a common. You can do n number of tasks. Okay. With this, I think we'll conclude for the day. Have a nice day. And please do comment. If you like it, please subscribe. Please like and share that everyone will require. The idea is to share the AI in a simple common term so everybody can understand. Okay. With this, the way I want to close the introduction. See you tomorrow or probably next video. We'll see you in the next video or next video. Okay. We'll go with a dig deeper into it. Okay. Thank you. Have a nice day.